True story. My family thinks I drive too fast. But I don't like, not street racer fast. You know what I mean? Okay. I bet the people that like watch the introduction to each of these videos and I'm talking about street racing, they're like, oh man, what was he talking about? I want to hear what he was talking. That's for us to know. This is like our own little like Las Vegas. What happens in 143 stays in 143. It does not get put out on the interweb, except the knowledge that I bestow upon you. Okay, so what about this one? Oi, oi, oi. Now we've done something similar to this before. We talked about what we can do here. So let's go here. Oh, I shouldn't have done that. Okay, let's go to our flow chart. Try to write all terms as variations of sine, cosine, or tangent. We have variations of sine only. Very good. Does the new equation have a squared trig term and a non-squared trig term? Indeed it does. Sine squared and sine. So yes. So what do? We set the equation equal to 0. Check. Then we factor. Now what does factoring look like with something like this? Okay, now in the previous problem it was just 2 terms. When you have 2 terms, a lot of the times that means taking out the greatest common factor, or maybe it's the difference of squares, but we don't have to worry about that. We're not going to go that, we're not going to get crazy with it. Now with this one, how many terms do we have? There's 2 operations, so we have 3 terms, right? Now the format, the bones of this problem should look familiar. Okay, what do we have? We have a squared term in the front. We have a, what I've called for now, 18 weeks, the floating constant that has no variable term with it. And then that thing that was squared in the front, it's not squared in the middle. So we would call this a quadratic trinomial, right? So a problem that looks like this isn't different, let's just go to a fresh sheet here, isn't really different from that. Something squared, a floating constant in the back, and that thing that's being squared, not squared in the middle, right? So this, I would hope, for the seniors in high school that have seen me demo this a dozen times probably, right? And you've seen it in Algebra 2 and you've seen it in Algebra 1. You should be very accomplished at factoring something that looks like that. We have a prime leading coefficient, so that has to go with one of these terms. Then I need to find the magic combination of numbers that multiply to be -1 and add to be +1 when this one gets multiplied by 2. And that magic combination, the only 2 numbers that multiply to be -1, whole numbers that is, or integers, are +1 and -1. And then check just to make sure. This would be 2a minus 1a. 2a minus 1a is 1a. So check just to make sure. This is what it would look like if I factored it with a. Well, this problem that we're looking at right now doesn't have a. It has sine x. So all I really have to do is replace the a's with sine x's. That's it. So I've simplified this problem. This was the negative, and this was the positive. By thinking about using just a variable instead of the sine x. Okay? So when you get a problem like this, if you're looking at this and you're like, sine x squared, sine x, what do I do with that? Replace sine x with a variable and factor that. You should be very good at this point in the game. And then, okay, we're not really doing a. This was a sine x. And this was a sine x being squared. Okay, so when we factor it, there you go. There's our factored form. There's our two binomials. We have two binomials because we had a trinomial to start. And then what do we do after we factor? We set each quantity equal to 0. So I take 2 sine x minus 1, and I set it equal to 0. I take sine x plus 1, and I set it equal to 0. And then I solve each one of these. Why don't you guys solve each one of those separately? Go. If you're at home watching this video, you can probably fast forward about a minute until we start talking about it. I want the people that are here to put some process into this. Ready? Okay. So, every time we have a trigonometric function with only one term, not a square term and a single term, but something simple like this, we isolate by adding 1 and dividing by 2. So we get sine x equals positive 1/2. And then my answer is the angle that has y coordinates, or the angles that have y coordinates of 1/2. And those two angles are pi over 6 and 5 pi over 6, using your unit circle. And then this equation only has one solution, because when I subtract the 1 over to the other side, there's only one angle that has a y coordinate of -1, and that angle is 3 pi over 2. There it is. Okay.